Okay, let's get to some test results and see what this linear bearing actually did on my rig. The first test is a very simple brake flex test. So I used the HE software to see how many kilograms of pressure I was putting on the brake pedal, and I just used a simple digital angle gauge that I use on my table saw to measure the angle. It's not precise, but gives me an indication. So with the linear bearing, I got 0.3 degrees of flex at 60 kilograms. Feeling pretty good about it at this point. So then I test it without the linear bearing, and surprisingly, those thick red springs didn't flex that much, and it went up to 0.5 degrees of flex. So, realistically, that's 40% of an improvement, but still nothing major or anything to be concerned about. So let's see what kind of an impact it had on the vibration. So what you can see here is that I'm putting the vibration data logger magnetic base on my tactile plate, which is steel, so it's holding very solidly. And you can see the way it's set up, it has a release so I can pull the data logger out while the base stays in place so that I can assure it's in the exact same position between my tests. The software for it isn't that great. I'm not highly recommending this device. I bought it mostly because of the price point and the magnetic base. I think it gave me the information that I needed, but once again, I'm not suggesting people run out and get this device. It's pretty old and the software is pretty old, and let's look at the results. So first thing you can see is I ran a test against my BKCT and my TST429 separately, and I ran it in SimHub, and I tested each frequency 3 times. I'd initiate it, and then I would up it 5 hertz and then do it 3 more times, up 5 hertz, 3 more times. And so the space between each of these little bars here is me changing the frequency by 5 hertz and then hitting it 3 times. So this doesn't mean a whole lot. Let's give you something with a little more data behind here. So you can see the CT, this is my initial test with the linear bearing still on, was giving me about 1.15 Gs, pretty much across the frequency range, plus or minus. And you can see the TST429 peaked at about 2.43. Now this is interesting later on, but one thing you can see here is from 70 to 80 hertz at the very end, you can see that diagonal dropping line. There's some attenuation, which doesn't mean much until you see the other results when I pull the linear bearings off. And you can see that the BK was up about 0.09 Gs, and the TST was up about 0.2 G. But this is interesting because it's going to point to the fact that alignment matters quite a bit on linear bearings. So I thought the next thing that I wanted to do is test it with 40 kilograms of brake pressure, just to see what the impact was with and without the linear bearing. Would it lock up the transducers and make all the vibrations go away? So first I did the testing without the linear bearing in place. So I'd done the initial test with it on, then I dropped it off, and while it was off, I applied about, it was probably 38 to 42 throughout this test range. I tried to hold it steady. And anyway, so this is what it looked like with 30 kilograms. And it ended up being about 2.65 for the peak on the TST. I'm just going to refer to that. So then I put the linear bearing back in, and I was surprised to see that the graph looked nearly the same under 40 kilograms of pressure. Now, you can tell this has the linear bearing because you can see where it drops off 40 or at 70, 75, and 80 hertz at the end. So you can tell this is the linear bearing version. And yet I was seeing 2.65 or so, which was the same as I was getting without the linear bearing. But with the 40 kilograms of pressure. So that got me thinking. Then I ran a test with the linear bearing still on without the brake pressure, and the results were really close to this. Now, there are two things. First, you can tell that simply removing the linear bearings and putting it back on, and I might have ended up swapping them when I bolted them back in, I got better results. The alignment made a difference, and a surprising amount of difference. The other thing I did was I increased the BKCT volume by about 1 tick, and that got it up to the level that I was getting before without the linear bearing. So that was simply added a little volume, and now I get the same result. Very cool. But the fact that the 40 kilograms of brake pressure had almost no impact on what I was feeling really surprised me. And so when we look to, somebody suggested I look at the X and Y components rather than just the Z, and this is a bit telling. So you can see without the linear bearings, on the right here, there's a lot more Y amplitude. And the BKCT is mounted towards the back of the plate, and the TST 429 is on the front of the plate. So they're rotating the plate slightly as they vibrate. So the TST is going to be vibrating a little more on the front, kind of hinging off the back, and the BK is on the back, kind of hinging off the front. So without the linear bearings, we see a lot more Y component. Now, as far as X component goes, both of the transducers are pretty well centered on my tactile plate. So the X did not change much at all. But what I'm thinking is that simply sitting in the seat is putting the linear bearing under load. So I'm not sitting perfectly centered upright in the seat. I'm leaning back into the seat. So I think just the fact that I'm sitting on the seat is putting some tension on the linear bearings. But the fact that I'm getting a more uniform output with the linear bearings on between braking and not braking, the effects feel about the same. I'm really surprised about that. The other thing, and that's actually the reason that someone suggested I look at the X and Y components you can see here, it got quieter with the linear bearing in place. And it was, I guess, keeping the tactile plate more captive where it wasn't vibrating as much forward and backward. It made a surprising drop in the volume of the tactile that I was getting. And so that's a big plus. So the other thing that I noticed is that the springs on my tactile plate are closer together left to right than they are front to back. They're much further spaced apart front to back. So they're more stable front to back, and that's good for braking purposes. But for my motion rig that's shaking me side to side as well, that's probably where I'm noticing the biggest improvement in the feel that I'm getting out of my motion system with the linear bearing in place. I'm actually able to, I'm not getting a rebound when I'm getting side-to-side motion, and the motion feels more direct, and it feels faster. It feels much more in sync with everything. I was surprised about the bit of lag that I was getting from the springs. So to conclude, I think that the linear bearings were an improvement. I think they're improving the motion feel quite a bit. It turns out they're making the tactile more consistent between when I'm braking and not braking, and they've made it quieter. So it feels like we've got 3 big positives. Now, there's cost involved, that's a negative, and there is some attenuation, but surprisingly, the attenuation is just equivalent to having about 40 kilograms of brake pressure on the normal springs. So overall, I can't complain. I think this is a very solid addition to my rig.